Thank you for having us. We're going to take you, we want to take you on a little journey of how this building became a reality from the beginning all the way to move in. And to start, those of you who are here for the tent show, you heard the story of the very how the museum originated. It started with the dream of one man. Caught that theme earlier. And Reverend Burke bought the Washington's tent for $5,000 and had the idea that he was going to tell the story of our nation's birth with a museum. It's really surprising to me to think that the Revolution itself and the start of our country didn't have a museum until now. And then the connection through history that the tent has been on is deserving of the exhibit that it has downstairs. Sorry. Yeah, these buttons are sensitive. All right. So there's a very interesting story for how the museum came to reside here downtown. Originally, the very small staff of a few dedicated individuals carrying out Reverend Burke's dream were able to catch the attention of fantastic benefactor and philanthropist Jerry Lenfest. Jerry decided that this was going to be part of his lifelong mission to be able to open this museum. He started by buying a plot of land immediately adjacent to Valley Forge Historical Park and working with the Park Service and what was then the American Revolution Center to get a land swap and an agreement set up that he would give the Park Service that property in exchange for the American Revolution Center, now a museum, to build a new museum and visitor center on the property. Stern's office won a competition for that design, and you can see it was very different than what we're in here in this environment in Old City. That agreement started to fall apart when the National Park Service decided that the idea of private groups being within federal property was not within their mission. So the Park Service went about another land swap to give this space, which was formerly the Visitor Center of Philadelphia. I want to just explain a little bit of how, my role coming in on the project was to hire this fantastic team, get the project started on a realistic schedule and a realistic budget. And everybody wonders, how does a small 5-person staff turn into 60 people and a full museum? You have to have a good funder, that's the start, but a realistic budget and schedule and an interpretive plan. So that's taking the mission of the museum and turning that into how are we going to explain it through the exhibits, as well as a business plan of how we're going to grow, how we're going to make our money. We also already had the site selected, so we hired Stern. You start getting going with the design work, and then that's when you start to go and look for your exhibit designer. You want the building to get off to a good start and then have the exhibit design follow closely behind so that the exhibit design can inform the building design, and the goal is to reach a magical dust-free point towards the end of construction where the exhibits can get pulled in and all of the magic with the scenic elements, the media coming in, all the AV hardware, all tie in. You do some soft opening and open to the public. For the Museum of the American Revolution, that looked like this 1, 2, 3, 4, 5.5 year process. This is the oversimplified schedule that we would present to the board on a monthly basis that obviously had Phil's 60-page detailed CPM schedule folded in with all of those things that we were tracking as well. Dennis is going to talk to you about how the design of the building evolved and how it came to be. One of the difficulties with this building in its site was logistics. Phil's going to talk about that. But also that you've got a lot of historic buildings around it informing the design. And the entire second floor as exhibits wants to be windowless. And museums need to attract people to them. So we had this long plan of a lot of signage and banners that we knew that we would need to get support from the Art Commission. There's a complicated process here in Philadelphia, especially with the historic overlay of this old city district to get to our approvals. The building looked very different when we went to the Art Commission. We had a blank facade along 3rd Street. The main entrance doors here, and we had this idea of a cupola and a bell. Some things get better with public input. So not only did the building get better, but this space that we're in is amazing. And that's a direct result of when we lost the bell, we gained the monitor. So being able to have the natural light into the space and then being able to have all the signage that we needed was a huge change for us. And that process and working hand in hand with the city and the other registered community organizations in the neighborhood also got immediate buy-in and brought us a lot of support leading up towards opening day. So Dennis is going to take us through the design.
Thank you for inviting me to this beautiful event. I'm speaking from more of a construction documents team. I joined the project in construction documentation phase. That's my role on a project. As you probably know, teaching the industry, it's a collaboration. It's all the teamwork. And before I start going through the plans and section, which are very few slides, I want to just say this is a collaboration. If you start listing credits for everybody who takes part in the designing the building it, it will be like a roll at the end of the movie with the credits. It's hundreds, more like thousands of people that actually put their work, thoughts into the project. And by the time I joined the team, first I came to the interview back in 2005, I believe, when it was still in the Valley Forge. And then I joined the team when it was already designed. So I'm sharing what I learned from the design principles. Again, there's a larger team that works. We start with cutting clay architectural plasticine as the original massing models. Then we turn over to the materials like foam core and paper and the museum board, build overall building models. Then we study interior spaces. And it's a process, it's not a linear process. We do things simultaneously, and we, at the same time, work with a team of consultants, which you can probably compare the architectural profession to a conductor of the orchestra, where you have to have every musical instrument with you. So we work with Keystone Hood. Alex is here to represent them, structural engineers. We worked with Altieri, who did the mechanical, electrical, plumbing, and fire protection. We did, Atelier 10 did the sustainability design and lighting design. We worked, Pinoni was the civil engineer, Allen was the landscape designer, and I'm probably missing, Healy Kohler was the exhibit designer implementing the actual exhibits. So again, this is a collaboration, and I think this whole evening is about not just the building design, which is, you know, designing the shell, the actual exterior of the building and its interior finishes is just part of the job. You'll see how elaborate just one exhibit, the jewel of this collection, the tent, how much of a separate design exercise that was. Or we'll go through the slides, you'll see how the main grand staircase has been designed with the help of the structural engineer. So one thing is to draw things on paper, and then the other way is to figure out how you're actually going to build it. So we are, the setting for the project is we're showing the site plan. We are in the eastern end of the Constitution Hall, steps away from the Independence Hall. You basically can walk in between the second bank and over to the Carpenter's Hall, which is over. You can just walk from the Constitution Mall to the museum, which is located on the intersection of 3rd Street and Chestnut. And the setting for the project, we are surrounded by the historical buildings that sort of draw the design of this building to be, as we call it, restrained classicism, which pays respect to the original classical buildings. We are just across the street from the first bank, of America. We are next to the Merchants Exchange, just south of us, and the Customs House, which is from 1934, a larger building in scale. So we pretty much had to figure out the massing, how to transition from a two-story classical building with a colonnade over to the, I can't remember how tall this building, the Customs House is, but it's a challenge. So you'll see these are the neighbors. The Independence Hall, the Carpenters Hall. This is just across the street from us, the Third Bank of the United States. This is the Merchants Exchange. This is from 1795. This is from 1834. And we designed the building so it could have respectful street facade with the setbacks that are stepping up towards the much larger in scale Customs House. At the same time, we try to keep with the requirement for the museum spaces being solid, windowless. We kept the storefronts in the windows at the street level along the 3rd Street, which is basically locating cafe, windows and doors, and the museum shop. And then the plaza of the corner, Chestnut 3rd, is the main entry to the museum. You would come into the museum, into the main rotunda. There's a separate entry for the school and group visits. It's pretty straightforward to be. You just walk the museum. You come in, you get your information and tickets at the front desk. You turn around and you immediately see the grand staircase that invites you to get into the core of the building that has temporary visits opening up, the orientation theater opening up onto it, the museum shop, the cafe. So all the spaces, public spaces of the museum are opening onto that grand staircase of the main atrium project, which is also communally crowded by the restrooms. The cafe kitchen is tucked away. The loading, which is important for the museum, is tucked away. You don't really see it. Quick dive to the lower level, which is important for the museums. They usually are collection storage needs to find room. So we were able to not just find the collection storage and bury most of the mechanical space under the ground, but also find room for 2 classrooms and the education center, plus the collection storage had a workroom that had glass. So if you're coming down to this level, you can actually see through the windows and the workroom, see how the restoration and conservation work is happening inside the workroom. Again, also, first we'll show you the slide. We also put the storm retainage system underneath the plaza, just the requirement to keep the storm water before it gets discharged into the street. So a lot of technical requirements that you have to keep in mind while you're designing the building. As you go up the building from the 1st floor, to the 2nd, up the grand staircase, or take the elevators, you find yourself, the stair brings you up to the entry to the main exhibits. They are designed as the sequence of galleries that are sort of like, you go from counterclockwise through the base. And that's, again, in itself was a separate exercise and design that we worked with Billy Fuller. And the mechanical engineers had to provide all the galleries layout. They're all different, get your better shape, get the air to them with different finishes. But again, you make the full circle around through the main exhibit space, permanent exhibits, and you come out back to the triple height featuring space that is skylit from the light monitor on top of the building. And here's also a pre-function space before you go into the Washington Theater. 3rd floor of the museum was predominantly offices for the museum workers and administration. There's a space for the boardroom. The offices have access to the awesome terrace, the eastern facing terrace, and then we are in the Liberty Hall, this double-height space that's well lit, probably so well that they keep the shades down, and which also has its own terrace overlooking towards the Independence Hall. Here's the basic section through the building. These are presentation drawings. I mean, of course, if you see the construction drawing set, which is hundreds of drawings, and they're all technical, these are just basic design party of the building. So you walk into the main space, you see the triple height main atrium, which is called after the United Indian Nation. You take the stairs up to the second floor, go to the galleries. And then the third floor is really just for events in the Liberty Hall and for the museum staff. That's the light monitor that sits on top of the building. There's a lay light above the atrium that brings natural light into this large space. And even though the building is very horizontal, when you look at it from the street, it appears very vertical when you're inside of it. So again, it's studied in smaller models and the larger scale models. We design things in the office. There's the so-called Bob Stern hole where he sticks his head in and he can look and feel the space. And that's like for larger models, for larger public spaces. So it's a whole fun process of designing the building, but it's also like constant deadlines, changing things until probably the very last moment and during the construction. So a few photographs after the building got completed. I have to say thank you to the museum for keeping this building so nicely. It opened in 2017. It's been 7 years at least. It looks just like when it opened. So that's important, and especially for the architect to be able to set foot back and be happy with how things look. I would say kudos to the museum for keeping it so nice. There's an Oculus at the main entry rotunda, which has the Washington Star in the design of the light fixture, and it implies that there's natural light coming in. Of course, there's Washington 10 feet right above us, and we're trying to achieve the extra height with the handkerchief wall. So the interior of the building is clad with silver shadow limestone. It's a two-tone terrazzo marble base with a two-step for the base, and then fairly simple trims and profiles, not really decorations. So a few shots of the main grand staircase looking up all the way to the light and the monitor above, bringing the natural light. You see the painting, the Yorktown, that was a separate exercise you'll see in this presentation to install the painting. The tent, I was talking to Dawn, I think I remember that the glass came from Switzerland, which is separate operation to procure it, to bring it over. So each part of the design process and construction process is a story. So I think we're here to tell you bits and pieces of this, and just show you that it's always a collaboration. It's not just the design team. We're in the Liberty Hall that opens up onto the terrace. And this is looking from the Ledger building across from the Independence Hall back to the museum, so you can see in scale. It's quite different from the Customs House, which is behind it, but when you look at it from the street corner, it still makes a lot of transition and makes sense and pays respect to the adjacent context. So that's I'll turn it over to Phil.
As the representative of the contractor who was fortunate to build the structure, my task was to talk through the construction of the job, and more particularly, I guess, some of the challenges that we faced during the demolition and construction phases. The site was originally occupied by the Visitor Center. The Visitor Center was built for the bicentennial. It wasn't a great structure. It kind of fit the bill, I guess, kind of thrown together quickly. At least that's what it seemed to us. But our first task was to demolish the Visitor Center to make way for the new construction. Unfortunately, the Visitor Center shared a party wall with the National Park Service building just to the south. And that shared party wall had a couple openings in it, 2 vestibules, some access to some shared toilet rooms. So in order to obviously make that shared party wall an exterior wall, we had to block up those openings, or the NPS had to block up those openings. So we had to do a little bit of selective demolition. Prior to the real demo, we had to expose some slabs. They poured some grade beams and then infilled the block to fully separate that party wall one side to the next. The buildings also shared some utilities. The central plant for the steam came out of the visitor center. So a bank of toilet rooms in the MPS building was converted to a new boiler plant to separate the two buildings. There was a shared electrical service that had to be disconnected and refed to the NPS building. And the sewer and water went through the visitor center site to feed the National Park Service building. So working with the City of Philadelphia, who I'll say with a lot of sarcasm is great to work with and really helpful, we managed to disconnect the structures from a utility perspective and isolate one building from the next. So, once that work was completed, we were then able to do the demolition of the structure. So through some asbestos remediation, some interior demo to pour some grade beams, some block infill, utility disconnects. At that point, we were ready to tackle the demolition of this structure. The first piece of the demolition was the bell tower. So the bell tower was constructed to house, I guess, was it a replica of the Liberty Bell?
It was the Queen's Bell. The Queen's Bell is now located in the Bicentennial Bell Garden across the way. So, yeah.
All right, I was going to say that, but you stole my thunder. So our first task was to take down the tallest piece of the structure, which was the bell tower. Our original plan was to put some manpower on high reaches, attack it with pneumatic hammers, and just take it down from the top. We quickly learned that the brick hid a pretty substantial reinforced concrete structure. So substantial that it may have been built to sustain another 200 years. Or maybe last through the next revolution. It was not going anywhere. And through about a week's worth of attacking it with hammers, I think anyone around us here in Old City probably felt like they were under siege with the amount of noise that emanated from that work. So we had to change gears. We engaged a concrete cutting company, put in place the biggest wire saw that I've ever seen erected on a project. We built a wire saw at grade level, ran it to the top of the structure, hung pinch points on the structure, wire sawed it in pieces, and lowered it to the ground so we could then attack it with hydraulic equipment mounted to machines, break it apart, and then cart it away. So our first challenge, we stumbled a little bit, but eventually did get past. This gives you a shot of the trussed roof structure, which was over the exhibit hall of the visitor center. And in this case, we actually got a little bit lucky. During the pre-construction phase, we actually found, the building facilities director found the picture in the upper right-hand corner, which shows the original erection of the visitor center roof. And what they did was they erected the truss assembly on the ground, and you can see that there's 4 cranes, one at each corner. Through a simultaneous pick, they erected the roof structure. So we borrowed from that a little bit. And we put 4 cranes in. We disconnected the roof structure from the assembly beneath, and through 4 cranes, we lowered it to the ground. And then that allowed us to dismantle it quicker, safer, made a little bit of headway in the effort. So, like I said, we got a little bit lucky. Shot of the truss up in the air on the ground and what that effort. The project logistics themselves were a challenge. We consider ourselves an urban contractor. A lot of what we do here in the city of Philadelphia is on constrained sites. We like to say we're used to that, but every site's a little bit different. And this particular site was hemmed in, on every elevation. On the south, obviously, was the National Park Service building, so there was a no-fly zone there. On the east side of the site is the Customs House, which is a GSA-controlled building. And American Way is the driveway that separates this building from theirs. And on the west and the north were 3rd Streets and Chestnut Streets. So from a logistics perspective, obviously the MPS building, no-fly zone, American Way, which is the driveway, the Customs House, had to remain passable at the end of each business day for safety purposes and emergency purposes. We took the sidewalk of 3rd Street, and that became our delivery lane. And the sidewalk along Chestnut Street was barely big enough to house a couple trailers. So all that said, that kind of forced us into a tower crane scenario, which if there are any contractors in the room, probably not many structures that you erect 3 stories or less with a tower crane. And this was the first for us. But the logistics were such that, because of there are some very large steel members on this building because of the size of the members, ultimately the precast loads that were coming behind, the constrained logistics, it forced us into a tower crane scenario. And because of the weights of the loads, it forced us into a diesel crane. So that we had the capacity to make the picks that we had to make later on. For those in the room that have heard a diesel crane under load, you can understand when I say we quickly endeared ourselves to the neighbors through the construction process. And one of those neighbors is a hotel. We got to know the neighbors very quickly, and some bribery along the way kept us going. Every project has a geotechnical report. It tells you where the rock is, tells you what's underground. We knew going in that we would hit groundwater. And we hit a lot of it. We had 2 3-inch pumps that ran continuously just to ensure that the hole was dry. Early on, we had portable generators. We had to have manpower come in every 8 hours to gas those generators up. Otherwise, we were not able to work the next day. So getting some semblance of permanent power to the site to power those pumps was a big deal. Like I said, those pumps ran 24 hours a day. And here in the city of Philadelphia, the existing stormwater infrastructure, it's not built to handle what comes off of a site. So our site work contractor put in a 30-yard container, built a filtration tank out of it with a couple weir structures, and we filtered the water and kind of slowed its release back into the storm system. I would tell you by the end of that effort, that 30-yard container looked a little bit like a wetlands with what was growing in it and what was coming out of it. But that picture there is indicative of what the site looked like permanently, 24 hours a day. I mean, that's how much water was coming out of the hole. So we're an old city, right? Like a lot of historic significance from Old City. We knew going in that we would encounter fragments of artifacts. We had an archaeologist on site with us full time who directed the excavation and who kind of said time out when we hit something that looked like it was of relevance or significance. And we hit it all over the site. As a contractor, one of the things that I look back on for the job, it's remarkable that during the construction, there's teams of archaeologists that are sifting, they're in a hole and they're sifting through soil, much like, panhandlers for gold. And we're pulling fragments of china and glass that are dime-sized pieces, right? It's hard for a contractor to relate to the fact that, what are we doing here? We need to go. We need to go. But thousands of pieces recovered, and the archaeologist took it back, cleaned it up, and refabricated, what you see on the screen. Just remarkable.
All those pieces all of those items are taped together with Scotch tape so that they can measure it, diagram it, document it, photograph it, figure out stories about it, then take it apart, put it in boxes, and send those boxes up to the State Museum to sit there. The bowl in the top right corner that says "Success to the Tritina" was found in one of the privies, and we learned that and some broken glass with a love note scratched into it allowed the archaeologists to determine that the admiral for the Trifina, which was the boat that took took Franklin over to France to convince the French to come help us, lived in that back corner. And his captain wrote a love note to his granddaughter who lived with him in the glass. I like puzzles, but trying to put together not just that stuff, but out of all the glass shards, finding the cursive Old English written into 500-year-old glass and putting it together to read the love note. We're just trusting that was a love note. And the bowl has been, the successor to the Trifina bowl is the only thing that has been reconserved to the point that it's on display downstairs. But yeah, it was one of those, every day I'd come onto the site and our superintendent, Robbie, would be like, and the archaeologist would go, guess what we found? Like, oh, I'm so excited for you.
Now, I hesitate to say this, but in our line of work, if we uncover something during excavation, our first instinct is to cover it back up and just keep digging. But when you have, I think at one point we probably had, I don't know, a dozen or a dozen and a half archaeologists on site, so we really had no latitude to cheat.
That was the other side, when more people started coming to participate. You're like, oh no. And now there's a book. There's actually a book on archaeology at the museum.
I don't care how good of a scheduler you are, you can't anticipate this. So it kind of goes at its own pace. But ultimately, the archaeologists did give us the green light that the site was fully canvassed and we were free to run. So that the hole was dry, archaeology behind us, and we went down. It's a deep hole. So all four sides of the basement were sheeted and shored. So steel I-beams, the soldier piles, and wood lagging to restrain the excavation. And the depth of the excavation was such that there were 2 rows of tiebacks to hold that shoring up and brace that shoring. Here in the city, one of the popular debates with tiebacks and shoring is who owns the rights under their buildings when you're running 45 or 50 foot rods under them to restrain the soldier piles. So it took at least a couple pre-con meetings with the National Park Service and the Customs House to convince them that at the end of the day, we would detension the rods and they would remain in place, but they would not hinder any potential future work on their property. So eventually we did get past that. We dug. That part of the installation went pretty quickly. The structure probably was pretty close to a mat footing. Maybe should have been a mat footing. We poured about 25 different mats throughout, but it's not a mat footing. So in hindsight, I think we all probably would have maybe looked at that a little bit differently. But gives you an idea of what it looked like prior to steel. Again, tower crane was diesel. This shows the steel structure, obviously pretty well ongoing. The tower crane mast came up through what is now the central stair, through the central court. Gives you a pic of the start of precast. The tower crane, like I said, was used to fully erect the steel with the exception of the roof structure through the crane mast area. We obviously started the precast panels with the tower crane, and we fully erected the precast on the south and east elevations facing the MPS building and the Customs House. And then ultimately, the crane had to go down. So you're making progress in construction when the crane comes down. It's a pretty big milestone. Crane came down. Conventional cranes were used to finish the balance of the precast with cranes staged right up against the elevation to ensure that the loads were pickable. And one of the things that a couple of these pictures show, you can see it obviously very clearly in a lot of these, is we shrink wrapped the building. It was a very complex building skin. Bill and his team, obviously, we did not rush them through the fabrication of the precast, but the job had a schedule. So how do you maintain schedule? How do you build significant interior work, sensitive plaster, all the finishes that you see when you walk through the building here? How do you do that without a building skin in place? We shrink wrapped the structure. And that allowed us to maintain momentum inside and give Bill and his group time to fabricate and time to erect the precast. In fact, much of the interior of the job was done by the time the building skin was fully buttoned up. Stormwater management here in the city of Philadelphia is a big deal. Again, the infrastructure is taxed. Converting, we didn't really convert pervious to impervious here, but we had to follow the rules as though we did. So detaining stormwater occurs via either cisterns or tanks that are within basements of buildings, or any number of solutions that are underground on the exterior. In this case, plastic arches that took the stormwater runoff from the roofs in the plaza and detained it. And actually, in the case of this structure, some of it's funneled back up to serve the cooling towers. A little bit of an interior shot. I think Alex is going to talk a little bit more about what went into the design and installation of the central stair, but a pretty massive self-supporting structure that actually doesn't get its due when you kind of see it up close. What this shot does show, obviously, is the tower crane comes out, the stair goes in, and then there's a choreography of manpower and material to get out of the building. And that's one thing when you're building, multifamily residential or corporate, office. But when you see the finishes that are in the central court here, just the terrazzo operation, just to hopscotch around and plan your way out of the building with 2 different terrazzo pours. Everyone kind of just got pushed out the exterior door as we made our way through to completion.
I think those pictures were taken at the same time, one looking up and one looking out.
This has nothing to do with construction, but in Old City there's a few bars around us. One night a bar fight turned into a gunfight on Chestnut Street. That turned into a police chase, which ended up the wrong way down Chestnut Street. That Cadillac crashed the fence, and I guess fortunately for the driver, they ran into the soldier piles that was restraining the excavation. Certainly not what the site engineer designs the soldier piles for, but they did keep the car from going in the hole. The next morning, our contractors found the handgun in the hole that was dispensed when he fled the scene. Our superintendent went to the police station with the firearm, closed the case. It just proves that every day in construction is different. Every day is an adventure. I think with that, Bill's going to talk about
Of course, I'm following a running gun battle, so I don't know if I can be quite as exciting as, Phil. We're talking about precast. Now, precast was selected on this job before. There was access reasons for just getting panels in certain spots, that it was not practical to erect scaffolding, hand-laid brick. But the original intention was hand-laid brick. So we had gotten involved with Phil, fairly early on, and started with just sketching up, here's how the job can be panelized, to work with this with precast and solve the problem of not being able to get. And you could also drop the panels in behind next to the National Park Service building in a very small space. And it helped with a lot of issues with the job. So the first picture we have here, you can see the top of some of the niche panels with the limestone and the barrel vault that's below. The top picture, now this is a panel out of the form, preliminary washed. It hasn't been caulked with the limestone, but it lets you see a little bit better all the little individual pieces of limestone that went into forming this. And a lot of these were very complex shapes. They had the curved surfaces, And one of the biggest challenges on the job, this limestone came from Alabama, I believe, was the lead time it took to get this. Because there was a lot of handwork on this limestone, and that was a challenge throughout the project, being able to source the limestone pieces that went into the panel. The form on the lower right there actually is a form set up, but not partially set up, I should say, for the barrel portion of the niche just below this panel. So that would be the panel just below this. Now, in this case, you can see, and I'll talk a little bit later, you can see there was a plastic reusable form liner here used to put the brick into. You're going to see a couple different kinds, and once you see the second kind, I'll mention a little bit, why there's pluses and minuses to both and why we had used both methods. Now, here's a picture of this is a piece very similar, but on the other side of the building where you do not have the limestone niche, but very similar forming. The lower right is a picture of the actual panel with the arch. It doesn't have the limestone in yet, but you can see how it's formed out in that kind of half sphere, quarter sphere shape to accept the limestone. Now, one thing I would like to point out is unusual for precast panels, typically, it's a soap brick. It's a half of an actual brick. In this particular case, the brick selection was very important because of the historical nature of the buildings around here and the desire to pick a brick that was blended well with the surrounding historical structures. So this brick was selected at the time, nearly 10 years ago. Traditional brick manufacturers didn't make thin brick so much. There was a much more limited number of thin brick manufacturers, and the selection was not as wide on textures and finishes. So this brick came from Watsontown Brick. It was a central Pennsylvania area, and it's an actual half brick. Now, you can imagine some of the challenges in cutting a brick that thick to fit the shape of this curve. Very difficult. It's a much more intensive process for us using that size brick. Now, this panel you'll see is a rubber form liner. And the advantage to a rubber form liner is it's highly reusable. And if you have, in this case, we had quite a few panels that had this shape, we could use that. In some instances where panels were only being cast, maybe single use, the plastic became more practical, as well as it can conform and bend around some of the curved shapes, which, as you can see, we have a lot of on this project. Now, part of the brick selection, this was early brick selection mock-ups, and a little bit of the discussion was pointing or not pointing brick. Typically, precast buildings, this is the actual precast. It's just, that's the mix of the precast coming out, formed in the joint. These panels are hand pointed. Obviously, that's an extra process, extra money, but it has a little bit more texture to it and looks a little natural. So the decision was made to use this process on the lower part, basically up to the first limestone band you see on the building. A little bit higher in some areas where there's not a limestone band. And then this was used above. And as you can see from back up there, essentially look very similar, but this is at eye level, so you can see the texture, or the kind of the sandy texture you get from hand pointing. And that, again, was keeping with the historical buildings in the area. Now, picking the brick early, again, it was a very hard process picking the brick. And I can remember, and I don't know if Dennis is the one who made me do this, but we delivered a 4-foot by 6-foot sample with brick in and stood it out in front of the National Park Service building, but it wasn't in the right light. So this thing that weighs like 600 pounds, we had Phil picked it up himself. Actually, he might have even helped. We had to like sit there and kind of waddle it across the plaza to get into the right light for people to look at it. So it was a lot of work to get the brick picked, but ended up everybody was very happy with the brick that was selected on the job. And again, it's a mix of these two methods for the way the brick was finished.
And just not to interrupt, but basically we first look at the brick, we bring samples to the adjacent buildings, we'll select the color first, and we find out this is a wire cut and molded brick that is not going to work with a precast. So you need to find a matching blend of brick or brick that would work with a precast with a flatness that would work.
And yes, it was a process. We went to many manufacturers, and like I say, we finally found one out in central Pennsylvania that fit the bill. This is a panel somewhere up here, somewhere on the upper level, which is all limestone, flat limestone. Now, this limestone was cast in with a somewhat traditional method of you have crossed stainless steel pins that get put into the back of the limestone, slip sheets put on to separate it because of the differential expansion of the limestone and the concrete, and then we pour the concrete on the back. Kind of traditional, straightforward method. And that was, again, the large panels that are up on these upper floors. Talk a little bit more about some of the specialty things that needed to be done on some of the limestone a couple slides from now. Now here's a panel. Again, when we pour the panel, there's a coating put on the panel, on the brick, so that concrete doesn't adhere to it if it leaks around into the form, which is then washed off. So you're seeing the panel right out of the form. And you can see just how many bricks go into this and the complex shapes. And we were able to pour a panel. These very complex panels, I think we poured one every 2 days on every deck. However, that's a lot of brick to set, which again, if you were hand laying it, would take a lot longer, and plus we're pouring on multiple decks. I will say, every single one of these bricks is drawn on our shop drawings. I mean, you draw it out to make sure it lays out and works. So,
Forcing the returns, the special shapes.
yeah, and you can see some special shapes a little bit clearer on some of the later slides. It's a little hard to tell when it's got all the film on. Now, this is a picture of a panel being washed. It's out there being washed, but what I'd like to point out here is you have some immense limestone pieces. This is basically a solid chunk of limestone. Those little 1/4-inch pins weren't going to do the job. So there was a lot of research and study done on just how to attach a piece of limestone that big to hang off the face of the precast. And the other advantage to the precast is, with all these complicated shapes, it basically sits on the thickness of the panel. So it does save a lot of interior support structure that all these ins and outs of the panel would have required. But now this limestone, we ended up using a deep, basically hilty, they're called hilty undercut anchors with a threaded hook bar in, and there was a lot of testing done at a testing lab to prove that the system would work and calc it out, because it's not typically used for this. Again, that's, limestone is not traditionally attached by this method. So a lot of laboratory testing went into developing connections for this limestone. And here's a panel that's pretty well cleaned up in storage, and you can see, now here's some of the, Dennis, alluded to, you get the shapes, the corner brick that returns, corners, so that it's not, the whole goal for this was, it was a hand-laid brick building, you want it to look like a hand-laid brick building. So there are shapes where you use it and you design it carefully, and that's why we draw every brick out, is so that you maintain that look, that to the average viewer, that's what you get.
At the same time, some of the bricks pop from the molds, and then we made a few of those come out.
Yeah, that's probably a little bit of, that's probably a replaced brick right there, because you get a little bit of anything, it's gone over brick by brick before it gets shipped out to the job site.
Multiple trips to the play.
Now here's the overall job at the end, and I just wanted to point out a few things here on what made this a successful job. And this is where the whole team effort in design. One, these were very big panels, which had the consequence of the crane needed to be very big, which a lot because of the weight of the precast panels. And that you're going to hear a little bit later how that impacted some other things. I mean, it all just kind of snowballs into something. But we wanted to keep it big so that, again, you wouldn't see a lot of joints. And you can see here, what helps is you have these little steps in the building. So we were able to make a continuous panel from one spot to the other. Joints occur inside there. You don't notice it. It happens at an inside corner. You're not seeing a lot of joints. What joints you do see, you know, any brick building is going to have some expansion joints, but it's not excessively jointed and it does not jump out. And that's kind of the whole thing. And kind of in summary, the goal here was we want it to look like the hand-laid brick building we've originally intended. And as I was thinking of this and where we're at in the Museum of the American Revolution, it's just after like 250 years, we're just kind of hearing now about, you know, how George Washington's network of spies played such a big role in winning the American Revolution, but you never heard about it. Well, that's kind of what, you know, we have great satisfaction that because the job was done well, nobody really knows you did it because it looks like a hand-laid brick building. And so now I'll turn things over to Alex. We're going to tell you about, now we put the skin on the building, he'll tell you about some of the inside structure.
Thank you very much. Yeah, the heaviest precast panel was 58,000 pounds on this building. So from a structural perspective, I wanted to share two projects within the project. One being the design of the monumental court stair, and the second being the support structure for George Washington's tent, which you got to see the video of earlier. So first, the stair. The stair is 37 feet long. It's 20 feet wide, and it's constructed of 16,000 pounds of curved steel. And it's designed to support about 160 people. And it's designed to look like it's floating, like it's cantilevering. So as you entered the building, you went up the stair to get to the tent theater. It was prefabricated off-site as 4 pieces, which you can see on the left here, 4 pieces which are sitting on the ground, each about 4,000 pounds. And then it was erected on temporary scaffolding and welded in place. The tower crane, Phil moved north right through one of our W30 girders. So we had to temporarily shore the girder, take out the middle third of it, and then CJP weld it back into place once the tower crane was out of the building. So that was a fun surprise for us. The monumental stair is actually a little bit of an illusionist. It's not actually floating. We have a series of 5 tie rods, which are perfectly aligned with the bronze pickets. They were perfectly coordinated between all the people sitting here, and we figured out exactly how to get them to be camouflaged so that nobody knows that 5 of those are actually structural. And if you walk up the stairs and you kind of hit them, you'll hear like a dunk, 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 and then a couple of them do like a dink, dink, dink. Those are the ones which are like the guitar wired. Don't cut the dink, dink, dinks. So those are the ones. The stair will still stand up if you cut them, but it will vibrate like you wouldn't believe. So we had to design for deflection, type vibration limits. As people leave the tent theater, and if they were to all walk down in lockstep, everybody stepping right, left, we want to make sure the stair doesn't vibrate or go into resonance. So if the stair is a little bit of an illusionist, oh, there's my arrows showing you where those hanger rods are. If the stair is a bit of an illusionist, the real smoke and mirrors happens in the tent theater, which I'm really happy that most, if not everybody, got to see the tent video and see the actual tent, George Washington's tent. So while we were working on the building as the structural engineer of record, Kirsty and the director of collections came to our firm and said, hey, would you be interested in designing a very different type of structure than a steel structure with 1,400 tons of steel? And we said, sure, what do you have in mind? And they were like, well, come out to this really nondescript warehouse in the suburbs of Philadelphia where all the artifacts were being stored with very little security. And we went in there.
Security was that no one knew where it was.
No one knew where it was. I don't even know where it was. You went in one door, go out the other door. Yeah, so we went in and laid out on the table, underneath of plastic, was George Washington's tent. And they said, we'd like you to design a structure to support George Washington's tent. And as a structural engineer, I said, sure, how much does it weigh? And they said, it weighs about 30 pounds. That's not a lot, okay. And I said, how tall is it? And they said, we don't know. We can't set it up. It's too fragile. It hasn't been set up in 100 years. And I said, oh, okay. Well, how long is it? How wide is it? And they said, we don't know. We can measure it on the ground, but we've never set it up. We don't know the contours. We don't know. So you need to design a structure, but we don't know the dimensions. And also, we don't want to see the structure. So design a structure, but make sure that it's not visible, and make sure that it doesn't touch the tent, because we can't have metal touching this fabric or it will disintegrate. And so we said, oh, okay, sure, give us a week. And they said, oh, and also we don't want an igloo. So don't give us a box that we're gonna put the tent on top of, because then it won't look like it's under tension. It won't look like fabric. It will look like an igloo, and we don't want an igloo. So we put our heads together at our office, and we came up with this concept of building a giant umbrella. An umbrella that's adjustable in height and width and length. And this was one of my first sketches to figure out what we would do. And this is what we ended up designing, and this is what's underneath of George Washington's tent now. It's an aluminum umbrella made of aircraft quality 6061 aluminum, and it has 25 ribs. Each of the ribs, like on an umbrella, sticks out to support where one of the ropes would come in to the tent. Each rib is on hinges so they can rotate back and forth, and each rib telescopes in and out 30 inches to give us that dimensional flexibility so we could figure out, once we set the thing up, that we could get it to meet the contours of the actual fabric tent. The way that this works is that the aluminum skeleton is constructed, and then a modern linen sub-tent is stretched taut over top of the skeleton. So this is a modern day sub-tent. So we're basically making a giant umbrella. And then the artifact, George Washington's tent, is very carefully draped over top of that umbrella as if it were a tablecloth. So it's under no tension, it's just sitting there. And so this is from our drawings. They're showing all the different degrees of adjustability that we were providing in our design. And you can see a scale figure of how big this thing is. So we'd never done it before. I'd never designed a support structure to support George Washington's tent. So we had to do a test. Sorry, not in my CV. So we tested it. We actually tested it here in 2013 in the building that was here. And this was a sub tent that was built over top of the aluminum structure, and it went really well. And I didn't get fired. But the one problem was we were worried about elongation. We were worried about this. This is going to be on display for decades, right? And we were worried that the linen sub-tent might actually creep or elongate over time if it's under continual tension. So we tested 6 different types of fabrics and found the one that had the least amount of elongation. But then the tent makers still wanted to incorporate this lacing that Kirsty and I affectionately refer to as the corset that's underneath of the tent. It basically is lacing so that over time, if the fabric elongates and stretches out, it can be tightened back up. And so that's the sub-tent. This was done in 2013, this was done in 2015, and then we put it away for 2 years, and it wasn't until 2017 that we installed the tent. During that time, fabric conservator Virginia Whalen spent over 500 hours conserving the tent, reinforcing the losses and making sure that it was ready to be on display because it was so fragile. It's 250 years old. Also in our court helping us were the good folks at Colonial Williamsburg in Virginia. They sewed a stunt double tent for us so that when it came to actually choreographing the install, we had a replica tent that we could work with. And so they were able to teach the public about George Washington and about tent making. And then we were able to use that tent when we needed to test out how we were going to actually install the artifact. So here's a photo of us installing the artifacts downstairs. Right below where we're sitting over here is the tent exhibit. And here's a literal peek behind the curtain. This is what you would see if you looked into the first Oval Office and looked up. You'd see the aluminum structure, which is completely adjustable with these oppositely threaded rods, hinges, the telescoping tubes that go in and out. Here's me 10 years ago, very happy that it worked. My favorite part about this entire thing is that the entire tent is adjustable with just one 3/8" wrench. So there's no fancy tool that the museum has to keep track of to make sure that they don't lose that thing so that they can actually adjust this in the future. It's just one 3/8" wrench, which I became very close with as I went around, and Kirsty and I figured out how to adjust this thing and get it into place. And here's...
You showed up, so I put my hands down.
Yeah, we were just like this for like 3 days straight, adjusting this. And then that was earlier before we had the corset. But here is the lacing and Michelle with the museum going through and perfectly tailoring the subtent for the actual contours of the fabric once it was installed. And then the ropes. So the ropes give the illusion that the tent is under some kind of a tension, but the ropes do nothing. They have a hook on the ground, and there's a rare earth magnet at the end of the rope. And there's rare earth magnets that have a little bit of mylar protecting the metal from the fabric at each one of the 33 ropes that go around the tent. So you could just pull them right off, and they're not actually obviously putting any tension on the tent. So with that, I'm going to turn it back over to Kirsty. Thanks.
So then as everybody is working on the building, we are also simultaneously designing and working our way through the exhibits. As Dennis mentioned, the galleries are set up in a chronological order, moving from when you come up the stairs all the way through. The exhibits are set up to answer 4 different questions. You know, how did loyal subjects turn into revolutionaries? How did the revolution survive its darkest hour? What was the radical nature of the revolution that they made? And then the contemplative part of what's the lasting meaning? And then within each of those subcategories, a lot of artifacts are displayed and tales are told to tie you back to be thinking about those questions as you move through the exhibits. As Dennis said, the list of people involved in the project is very long. And what's really interesting here is that every single person who touched this project also touched that tent theater. Everybody from the sprinkler contractor to, you know, the precast on the outside because the temperature control for that tent was really specific, to the guy that put the sealants in who pointed out to us that, hey, I once used a really ultra clear sealant between these ultra clear glass panels and it sent bubbles all up through the cavity of the glass. We went, oh crap, don't do that. And it took 8 months for this stuff to come across the ocean, and it was 8 months before that, and so learned actually we will just not put the sealant in between, and that little bit of air movement actually keeps the dust off of the tent. They've only had to vacuum it 3 times, and we thought we were going to be vacuuming it 3 or 4 times a year. The ship is modeled on the Trifina. That was just by accident. It was like fate that we found the bowl because the Trifina happened to be one of the most well-documented and well-drawn ships. The Seaport Museum built this ship as a kit of parts in their shop at the museum, put it on a truck and drove it over here. But while they were working on that, the bowsprit and the mast and the bowsprit were too large to get into the museum after it was built. So those were delivered just after the floors were poured and put on little dollies and lovingly moved around the museum, tripped over, cursed at, until finally a year later, they were able to get reassembled as part of the ship. Some of the photos down here, this is a union environment here in Philadelphia, and we had union contractors, but the ship was built by the Seaport by their staff, and they wanted to put it back together themselves. So Phil and Intech helped us bridge a agreement with the carpenters union that we would have 2 carpenters with the 2 Seaport Museum guys, and that team of 4 loved their job. It was such a success. The 2 carpenters were so excited to be working on something different, really learned a lot, and it turned out beautifully. There's a lot of the behind the scenes. It's fun to go to the precast shop. It's also fun to go to the figure and tableau shop. My favorite part about this, first, the horses died of natural causes, I've been told. The 2 guys, Joe and Joe, who built these figures, when they had to come up with the faces, just used each other. So when it came time to install this, I turned the corner and there's Joe in his overalls putting Joe onto the horse, and I'm like, whoa. And I wish I had gotten the picture of him posing with the same face, because they're identical, a little spooky. We also had, the tree was made in a shop just down by the airport. That took about 9.5 months of fabrication, so they got started with that. That was like one of the first things. Okay, we know we have a tree, we're designing around the tree, this is where the tree is gonna go. As you're, grading your 100th paper at 10:30 at night, just be glad you're not placing every one of those artificial leaves by hand yourself on the tree. When you're putting all of these articles and artifacts and paintings into the cases, it's not like hanging the photo at your house where it's a little bit up to the left, no, over a little to the right. You have to lay everything out. You have to plan out every line of text so that you have space for everything to fit. And some of these mounts are hiding secure mounts. Some of them are just on with 3M stickies, but it just depends on the level of security. There's a lot of AV in this building, and it took a lot of coordination with Intech. We had just as many meetings with the AV folks to make sure that the power and the data and was all going to the right place as we did with the precast anchors. And then some of the other really interesting things that you don't think about until you're involved is, okay, we're borrowing a lot of these artifacts that are on display are borrowed or loaned from people, and the rules and regulations that they have for how it's going to be transported into the building, stored and secured, are greater than what you have for some of your own belongings. So there was a lot of work that went into that. Alex actually pointed out to all of us when we were working on it with one of the stunt doubles, you're done conserving the tent and we bring it in, how do we unfold it and then actually install it over the structure? So we practiced about a dozen times of how to take the stunt double tent, fold it into the size that she could put into her car, and bring it here up on the freight elevator, and then unfold it in the tent area, the place between the glass and the seats, then get it up onto, we made a sling, like a special sling for it, that then we could hold it and drive it into the tent, because the building had to be done and everything had to be, and we just had that 1 3-foot door. So a lot of practice went into just even how we were going to unfold and fold Washington's artifact and how it was going to go up onto the structure. And even Virginia was like, actually, Alex can tell everybody how to do this part. She's like, I don't want the responsibility. Some things are tedious and tiny, and then some things are, large and cumbersome. The putting together it was a week and a half just to get all of the arms into the arms case. The painting of Yorktown that's in the main atrium was too large for anyone to conserve at their shop. So we worked out with the painting conservator, as well as with the artist who made the frame for this, is a replica of the frame that surrounds the other print of the siege at York, this render at Yorktown, that's hanging at Versailles. So this is an exact model on that painting and frame. We had to reach dust-free in the atrium at a time when the exhibit folks really wanted to have free reign and be able to run back and forth between the galleries. And I turned the atrium space into a painting conservation dust-free zone so that they could have 8 weeks to conserve the painting. Then put that and secure it, then bring the frame in pieces. And the artist who made the frame surprised me with bringing it in 2 L-shaped pieces instead of 4 single pieces. So we had to grab a few extra people from the art handling company to carry it up the steps and bring it up the steps instead of through the loading dock. But the end result is stunning. Now we'll take any questions.
I think we have a few minutes. First of all, I hope you enjoyed that as much as I did. It's just amazing what it takes in the timeline to build something as beautiful as this building. Does anybody, I think we can take a few questions. I have a few mics up here. Does anybody have any questions? Ron, any questions?
Great presentation. I was wondering, did you write a paper on this yet? Anyway.
There's an article in Civil Engineering magazine about the structure of the building that East Code wrote.
So I have 2 questions. The first one for you, Alex. You had the umbrella. Was that bolted onto the ground?
Yes, the umbrella structure is bolted to the ground, but we had to have slotted holes because we didn't know exactly where to bolt it. So it had to be able to move back and forth until we had the tent in place.
Okay. Now, on the brick, what attaches the brick to the precast?
It's basically just the bond between the concrete and the brick. And actually, we've done pull-out tests. These are thick bricks, so there's a lot of physical bond there. But even on a thin brick, you'll shear the brick apart before you can pull it out of the concrete.
Even after 100 years? Looking ahead into the future? I'm saying long term.
Long term, yeah, we've done testing as well in laboratory testing and through freeze thaw and everything, and it stays on. It's not coming out of there.
Okay, thank you so much. Great project.
Thank you. All right, well, before we conclude, yep.
I just had a question about the conservation of the tents. What was the reason why that the linen couldn't touch the aluminum?
Because they didn't want the aluminum in contact with the historic canvas of the tent. And they were okay with the sub-tent, which was a natural linen, being in contact with the tent, which was also a natural canvas. They were okay with that contact, but they didn't want the metal in contact with the linen because they thought it could corrode or discolor the artifact.
All right, well, thank you all so much. It was just such an amazing presentation. I can see how important this project was to you and how special the relationship, the collaboration amongst all of you. I think that's what made it really special. So thanks again for having it.